This woman is not running a word processor. She's a computer scientist at the FBI trying to solve a crime. In fact, law enforcement agencies all around the country are turning to computers to try to make police work more efficient and more effective. Today, we take a look at computers as crime stoppers on this edition of the Computer Chronicles.
The Computer Chronicles is made possible in part by a grant from AFIPS, the American Federation of Information Processing Societies. AFIPS, sponsors of OAC 86, the nation's leading conference on business technology. For conference information, call 800-OAC-1986. Exploring today's business solutions. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover the latest in microcomputer technology worldwide. Byte, the international standard.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and this is Gary Kildall. Gary, on the computer we have a game called Murder by the Dozen, in which I play a detective in the city of Metropolis, and I'm trying to solve a crime. And you can see one of the tools I have available to me is a crime computer. And I can call up the computer, and it gives me some clues as to who the suspect might be in this crime. Well, this is just a game, but in fact, real policemen are using real computers to nab real criminals these days. Is this another example, Gary, of one of these vertical applications we've seen before of the computer's incredible ability to massage massive amounts of data?
Well, Stuart, I think it's that and a whole lot more, because not only data records, we're dealing with graphical materials like fingerprints, photographs, things of that sort. And it's a situation now where no one person can deal with these things on 3x5 cards, scraps of paper, and phone calls. So it's going to be interesting to see how computer technology, data communications, database systems are applied in this area where we need to have rapid access to information like that.
Well, on today's program, we're going to take a look at computers in law enforcement. We'll see a supercomputer that can sort through millions of fingerprints in a matter of seconds. We'll see the computers that go into action when you dial 911, and we'll take a look at the latest artificial intelligence systems being used by the FBI. We're going to begin by looking at a $1 million computer that helped nab the prime suspect in California's infamous Night Stalker case.
Since Scotland Yard began using fingerprints to track criminals in the 19th century, law enforcement agencies have faced the uncomfortable fact that a fingerprint without a suspect is often useless. To match a smudged partial print taken from the scene of a crime to one of the millions on file is so time-consuming that a criminal is likely to die before an accurate match is made. But to break this intricate code of loops and ridges that makes every person unique, the California Department of Justice has replaced its 7 million fingerprint cards with billion-byte optical discs, exchanged manual searches with a pattern search by computer, and the results have been rewarding.
In the UCLA murder-kidnap case of the two young people, the only available print was very, very faint. It was lifted from a car that had been torched to try to destroy any clues. And it's a perfect example of a case that would never have been solved without Cal ID. Now, to match this particular print, we had to search over 3 million records, that is 3 million individual prints. We estimate that it would have taken our fingerprint specialist 67 years to do that search manually. Cal ID did it in less than 20 minutes, and of course we got our man.
To match suspect with print, the $22 million NEC supercomputer searches through 12 million digitized prints at a rate of 12,000 per second. As the prints come in, they are scanned and electronically traced. Unclear areas are zoned out with a light pen. Minutia, or the identification points of a fingerprint, are mapped out according to the number of ridge lines between one point and its 4 closest neighbors. It's the relative position of each point to the others that the computer considers when looking for a match. Each print is given a score, indicating the probability of an exact match. But the final confirmation is still done by a human being. The Cal ID system will ultimately offer remote access so that local police departments can get immediate help from the world's fastest and most accurate sleuth.
Joining us now in the studio is Louise Anderson, the marketing coordinator for Command Data Systems of Dublin, California. And next to her, Captain Steve Port of the Hawthorne, California Police Department. Gary?
Stuart, I'm just going to start out with a real simple question. How has the use of computers really helped you as a police officer? You've been with the Hawthorne Police Department for a number of years. What have you seen change?
I've seen a lot change. It's helped us greatly. We broke into with computer-aided dispatch almost 10 years ago, what you'll see here today, and it greatly simplified the call routing, finding out what officers are available and getting us to the calls faster and more efficiently.
Well, what about this 911 system that we've heard about?
The 911 system has been really great in that when people call the police, we find out immediately where they are, what address they're calling from, can verify what's going on, and get the police going there much faster. Sometimes it's very hard to elicit information from someone that's very upset and afraid.
Louise, at the dispatch end, briefly, how does, you have on your VAC system this computer-aided dispatch, how would it work when I dial 911?
When you dial 911, what will appear at the bottom of the dispatcher's screen is the information associated with the phone number that you're calling from. The dispatcher then will verify, is that where the problem is.
Suppose I'm real nervous and panicked and I say I'm at an Alpha Beta supermarket.
What we can do is then have the computer check to see how many Alpha Betas are in the area, and then the dispatcher can say, are you at the one at Farmers Lane? Are you at the one here? And you can go ahead and key that in.
So this helps coordinate all the dispatching and the collection of information and so forth through a central computer system all at once.
That's right. Also really makes sure that we are sending officers to the right place.
Right. Okay. Now there's also another system that, Louise, you have that collects various pieces of information and kind of gets the clues all together. Can you show us that?
That's right. That's our Sherlock crime analysis system. And what we use that for is to do searches when you don't know a person's name or you don't know a case number. I mean, those things you could, in the past, look up on a 3x5 card.
Well, this is sort of, you know, a bunch of facts and you're trying to get the
So you mean witnesses might say, well, the car is something like this and the guy looked something like that and you're trying to track it down.
Okay.
Right.
That's right. What we'll do on this is we will look for an older model Chevy or Ford. So I'm going to say, as a crime analyst, that an older model is from 1960 to 1970. And I'll say, okay, I want the Chevys or the Fords. And that's all I know. In the past, you just would not be able to do a search like this.
How big is the database that you're using for the search like this?
This kind of depends.
How many people would be involved in this thing?
This is our demo database, so we don't have as many people. In a regular police department, you may have 300 to 400 people in your known offender file.
Yeah, let's track down 8 cars, which are Chevys or Fords between a 60 and a 70. Okay, what do you do next with, say, the person's description?
Okay, say that the detective comes and says, okay, I've talked to some witnesses and now I've got a description of a person. What I can do is look at the people who are associated with these 8 vehicles and really narrow it down.
Okay, so you will now enter just a limited amount of descriptive information about a suspect.
That's right, because a lot of times, you know, people think that they have seen a lot from the scene, but they really haven't, or it's just not able to be verified.
So the detective says he was a middle-aged white male. What do you do?
Okay, so say white male. Cop work, middle-aged, is anybody over 30. So I'm going to say 30 to 45, and say he's kind of a medium height. So I'm going to say he's 5'8" to 5'10", and that's all I know.
Okay, so your computer's now searching all the records of what information you have on
people who have been arrested for crimes.
Okay, these are past arrest records.
That's right.
Okay, to see if anybody meets those, well, you did it. So what's it tell you?
We have one person, and as a crime analyst, what I would do is go pull that person's record and take it over to the detective and say, here's your guy.
Steve, has this in fact made crime fighting more efficient? I mean, do you have a higher percentage of arrests and convictions because of your computer information?
Well, I think it's hard to say at this rate. The beauty of this, what Louise just showed you, is that not just Louise, but any officer can get this information from the computer. You don't have to go to one central focal point and say, please do this inquiry for me. Any officer with some training can sit down and extract that same kind of information based on his investigation from the computer. So from that standpoint, yeah, we're more productive because we're able to grab the information, go use it, get a real fast turnaround, and probably solve some more crimes.
Okay, we're going to get back to you in just a minute. As you might suspect, one of the most high-tech police companies in the country is right here in the Silicon Valley in San Jose. Our reporter Wendy Woods went out and rode in a San Jose police car to see how they use computers.
For years, emergency and police services kept track of units in the field through the old card-on-a-peg method. Today, more and more of them have computerized virtually every aspect of dispatch services. And the San Jose Police Department is among a handful who've taken computers one step further. All the command officers' squad cars are equipped with mobile computer terminals, which provide officers with access to the location and status of all units in the field, as well as a variety of motor vehicle and crime record information from state and national databases.
When the system is down, or like the week we didn't have them when we were changing over to our new units, you really feel lost without them. It's sort of like being in a dark tunnel and no lights being available. You don't know what's happening in the district. You really have to listen to the radio to catch every little thing. And you spend a lot of time asking the dispatcher, how many units do I have? Do we have any calls pending in the district? Which just takes up more valuable radio time.
The 48 mobile units access a separate radio frequency and are interfaced to the county's giant digital mini-computers, which control the entire dispatch system, via one simple IBM PC. The system has worked flawlessly since its installation 6 months ago. Within the next few years, virtually all metropolitan police departments are expected to have installed mobile terminals in their squad cars. Now that the terminals are smaller, they are less conspicuous, and their power to help an officer has never been more significant. For the Computer Chronicles, I'm Wendy Woods.
While we were watching Wendy's report, Louise and Steve have set up another program here that runs on a PC.
Yeah, we had a little switch in gears here. We're not talking over a telephone line. I have a regular a compact sitting underneath the table here. Steve, can you tell us what this program does?
What Louise and I want to show you is land track software, and what it does is it goes against the database with some graphics software. It's a map of the city here, and what we'd like to do is to extract from the database all the robberies that occurred between a certain amount of time within the last 30 days. So let's say between noon and 10 o'clock in the last 30 days. It goes out to the database and plots those crimes on the map.
So each one of those dots represents the location of a crime.
That's right. As you can see, they're lined up, many of them along some of the major streets in this area. And so what we would do is use this information visually to go with the police lieutenants, police sergeants, and ask them to come up with a plan, how to deploy, how to deal with these crimes at the time when they're occurring, and look for the types of people that are doing them with some crime analysis information.
So this information can be fairly up to date then?
Oh yes, every day. As a matter of fact, it can be updated every day.
Now, Steve, suppose you want to go backwards now and ask Louise, I want to know exactly what kind of crime was committed on that green thoroughfare there. Can she do that?
All she has to do is center the crosshair on one of the asterisks, and it'll just show a profile of the crime on the lower screen.
Okay, so you're pulling up now the Word file that supports the crime that took place at that particular location, and there it is.
Right, and it gives you a profile of the type of crime. In this case, it's a robbery that occurred on Breezewood Drive, the time of day, the officer that took the report, and just gives you a real good idea of the specifics of the crime.
Now, you also have some things on the panel here that say area zoom, slide, and so forth. What do these other functions do?
That's some different functionality of the software. You can zoom in on a certain area, in this case some reporting districts, certain street segments. You can edit some of the things that are in there if you want to change that. There's just a number of functions you can see listed right there. The mouse enables you to do that.
And Louise, these systems are actually in use now. This is not just
That's right. In addition to Hawthorne, there's one at Norwalk. We also have been contracted to install them in several other places.
Thank you very, very much. Now, in just a minute, we're going to go to Washington and visit the FBI to see the absolute latest in computers that help to fight crime. So stay with us.
This is FBI headquarters in the nation's capital. If anybody should know how to use computers to catch crooks, it ought to be these guys, and they do know how, with a sophisticated collection of the latest computer hardware and software. The FBI has invested $500 million in computers. They have 7 mainframes, many with coupled backups, here at the National Crime Information Center. The statistics here are overwhelming. 250 billion characters of mass storage, 17 million records, 500,000 transactions a day. And talk about networks, there are 20,000 terminals accessing this system. Computers have given the FBI investigative capabilities which it never could have had in the days of 3x5 index cards. One example is a recent murder case involving a judge in Texas.
An alibi for one of the suspects was that he was in a different place. We went through all the hotel registrations looking for that suspect's name or aliases. By using a computer search logic and matching logic for dates and aliases and names, we were able then to identify the fact and pinpoint the fact that our prime suspect was, in fact, in San Antonio the night of the murder.
One of the FBI's top priorities is domestic terrorism. And with its new computer systems, it can now provide sophisticated intelligence even to agents in the field.
An agent is driving his car on Route 10 out of El Paso heading west, following a van with suspected terrorists. He can now look forward to accessing any database in the FBI from that car while he's driving it in real time, and he'll be able to do it while he's driving, and he can still maintain his visual surveillance of this suspected terrorist vehicle.
The FBI also uses computer-generated behavior profiles. In a hostage crisis, the agency consults its computers to predict terrorist behavior so as to help develop its negotiating strategy. The behavior profiles are used not only to catch criminals after the crime has been committed, but to prevent crimes from happening in the first place.
We have a file that's sponsored by the U.S. Secret Service of threats to federal protectees, the president and others who are protected under the law. After that file had been activated for 1 hour, there was a hit on the system of someone on his way to Washington with a threat against the president. For the first time, the U.S. Secret Service has the capability now of knowing where people are who are out there, who are not under arrest or under detention, but who are threats, legitimate threats.
The FBI is most proud of its use of artificial intelligence, in particular OSIS, the Organized Crime Information System. It's an expert system using engineered knowledge from the FBI's top agents. It applies its rules to a massive database looking for suspicious conduct. For example, in this fictionalized demonstration, the FBI agent can investigate a particular individual or organization, ask the computer to explore a variety of paths, ask the computer why it's recommending a course of action or what it knows in a particular area. OSIS can even graph suspected illegal relationships, and on demand, it can pop up a profile of any suspect.
Gary, we didn't get to see some of the best stuff at the FBI because of security considerations, but I assure you their computer systems are very sophisticated.
Well, we'll have some of our own sophistication on this segment.
I think so. Let me introduce the two guests who have joined us now. Dr. Earlene Bush, who's the president of Information Access Systems of Boulder, Colorado, and David Hall, the director of Information System Programs at Search Group Incorporated of Sacramento.
Earlene, would you tell us about Probe 1?
Probe 1 is an investigative information management system. That is, it is a professional support system for the investigators. In your earlier segment, you had command data system on which had Sherlock. I think ours could be called Watson.
Okay. Show us what Watson can do here.
Essentially what it does, I'll skip the duller part, allows investigators to enter requests for modus operandi in their own words. In this case, I'm asking the system, I'm pretending as if I'm a detective, I'm asking this system to give me documents in which there was a homicide, the victim was assaulted, and the body was found in the car. Simply that. The system comes back and says it's working. What it's doing, it's handling my request like a document. That is, it is determining the subject matter of the document.
Now, where the source of the material in this case, what is it searching?
It's searching actually a series of telexes on homicides. We have changed all the proper names and facts.
Now, an investigator normally would have to read all this material, trying to assimilate it, figure out what's relevant, what isn't relevant. In this
Not only would they have to read it, they have to go find it first. So essentially the system works like a very good research assistant.
So what did the system tell you?
Okay, first of all, the system came back and told me that there are 28 documents that are relevant to my request, and it rank ordered them for me.
Now, excuse me, you say relevant to your request, that means what?
In human, very human terms, it is like it in subject matter.
Okay, it found other cases dealing with victims assaulted and found in cars.
Correct.
Okay, and specifically, what's it tell you?
And it tells me how close. That is, the first one is quite close. It would be a bullseye if we're right on, so to speak. The second and third are quite distant, and they are close to each other.
Okay, can we take a look at this one here?
Okay, so you can pull up the record now on that first document, which the computer says is very similar to the situation you described.
That's correct.
Which means it might have been committed by the same guy, for example.
That is the general concept behind modus
Okay.
operandi, that a pattern will be repeated.
Okay, what's it tell you?
Okay, it is describing a woman who was assaulted and beaten and left. She was handcuffed to the car. However, the document does not contain the term homicide, which would be a basic requirement in any kind of a keyword technology.
Okay.
However,
Tell us a little bit about the technology.
Okay,
What's
the
now, in the sense
technology-
of, let's take the sentence itself. Do you take it apart, parse it, figure out where the verbs and adjectives and so forth are?
No, what we do on the front end is tell the system the subject matter that it's going to be handling. In this case, it's handling homicides. In another installation we did, it was handling mining support documents.
Okay.
In yet another, it's handling legal library.
All right, so there's certain words in there that would just be placeholders, the and or and so forth. Words
Those
of that
are
sort.
ignored.
Okay, and
Absolutely.
so now how do you actually then perform this matching process? You pre-analyze all these documents and figure out correspond the words to one another?
No, we analyze the subject matter and the terms that make distinctions between subject matters, such as
Okay.
tire castings relate to crime scene
I see,
investigation,
okay.
whereas victim relates to homicide.
David, now this system is being used, as I understand, in the state of Washington in the Green River murder case investigation, which has been unsolved. You work with police departments all over the country. How much do police departments share these kinds of databases and this kind of information?
Databases of the type that Erlene is talking about here are very difficult to share because of the very nature of them. They have to send the documents back and forth. There's no system designed right now to be able to transfer those systems back and forth easily. You have to know what you're looking for when you contact another police department and ask them for something.
Do you see that trend changing, though? Are we going to start to see an integration of these systems or not?
I believe with the development of this type of system and other systems of this type, as you refer to the FBI, that we will see a much greater sharing of this kind of information.
How frequently are these kinds of sophisticated systems used? I mean, is cost a major factor in whether or not a police department can get into this kind of computer support?
Definitely. Trying to derive the funds from the municipalities or states or counties involved is a difficult process, and procurement of this type of system is very difficult.
Is
very
there?
costly.
I'm sorry, Gary. You want to...
Well, there's always a question whenever we're talking about large databases and this question of access and locks and keys and so forth. Do you see this coming up also in the collection of information about people related to crime?
It depends on who has access to the information. The primary thing we're concerned about is who's going to have access to what type of information or what circumstances. Information of this type that we're referring to would be only open to law enforcement, criminal justice agencies, and this wouldn't be something that we would see out in the public that would maybe hit the newspapers or something like that, because it's of the type of system that it is.
Erlene, is the use of the probe system in the Green River murder case the first time this has been used in that way?
In that way, yes. The other application was office automation.
And what's the feedback been so far? What do the police in Washington State think about this?
Well, I would have liked to have had Officer Shoemaker on the show because he is the system manager there, is quite familiar with the technology and quite enthusiastic.
Okay, and also there's always a question that comes up also in programs like this, is that how much decision-making would be made by the programmer, in the sense that when the program put it together, there leads to certain cases that more often than others. Do the investigators actually go back and check and make sure that these were relevant cases?
I mean, the computers don't make the decisions. They simply advise.
The judgment the computer makes is simply in reference to the document base and certain documents being related to the request.
They're aware that they should rely
We're out
upon
of time.
the
Thank you very much. Now, it's fascinating to have this incredible computer ability to help law enforcement officials in finding criminals. There are some concerns, of course, about these massive databases and what can be done with them. They raise some classic techno-ethical questions, and our commentator George Morrow tries to provide some answers.
One seldom hears computers mentioned in complaints having to do with law enforcement. I don't mean to suggest we have nothing to worry about in this area. However, the techniques used in audit trail checks and security access logs, which protect operating systems and accounting software, are tools which can keep the abuse of information by law enforcement personnel to a minimum. We do need safeguards in this area. But equally important, we need to realize that the very nature of crime makes computers potentially a productive tool for our police departments. Criminals almost always repeat the way they commit a crime, and computers are particularly good at spotting and analyzing repetitive patterns. Also, they can save time and effort with the myriad of paperwork which is becoming a larger part of a policeman's day, whether in connection with a crime or as part of something as simple and routine as an auto accident. Today, there is fierce competition for our tax dollars, which will not change in the near future. Computers can make these tax dollars work harder for us in law enforcement. That's how I see it. I'm George Morrow.
In the Random Access file this week, it looks like January 21st will be the day that IBM finally releases several long-awaited new products. Expected to be introduced that day are the Clamshell Laptop Portable and the new TopView 1.1. The new version of TopView will reportedly add networking features and support for 3.5-inch floppy disk drives, but it apparently will not solve the problem of the 640K limits of MS-DOS. Atari reportedly plans to introduce a new upgraded version of the 520 ST. The new computer will be called the 1040 ST, and as the name implies, will feature over 1 megabyte of memory. The 1040 will also improve on the 520 by integrating the power supply and the disk drive into the main unit, thus eliminating the current cable mess with the 520. Atari also announced that a new version of the 520 ST with an RF converter will start showing up on the shelves of mass merchandise stores like Kmart and Toys R Us. In our legislative update file, several major pieces of computer legislation remain unfinished as Congress reconvenes for 1986. They include bills on copyright protection, computer crime and computer privacy, and provisions for R&D tax credits. Epson and Toshiba have announced the development of new color LCD displays for computers. Epson says its new 5-inch screen is 10 times brighter than existing black and white LCD screens with a resolution of 480 by 440 pixels. A California optometrist says the reason computer users suffer eye strain is because the eyes focus on a point beyond the plane of the screen. So he has come up with a VDT template, which he says helps you focus your eyes at the right level. It's called EyeSaver, and it costs $15. Well, doctors may not make house calls anymore, but a new program called House Call may be a substitute. Its developers say it turns your PC into an MD with the ability to diagnose some 400 common medical problems. House Call comes on 2 double-sided, double-density discs and sells for $40. Finally, if you've seen the movie Young Sherlock Holmes and wondered how they made that stained glass man jump out of the window and wave his blood-tipped sword, the answer is a new graphics computer from Industrial Light and Magic, a division of Lucasfilms. The computer is called Pixar, and it not only created the image, but it electronically combined it via laser scanning with the existing film footage of the actor. Those 38 seconds of the film took Pixar and 6 engineers 9 months to create. That's it for this week's Computer Chronicles. We'll see you again next time.
The Computer Chronicles is made possible in part by a grant from AFIPS, the American Federation of Information Processing Societies. AFIPS, sponsors of OAC 86, the nation's leading conference on business technology. For conference information, call 800-OAC-1986. Exploring today's business solutions. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover the latest in microcomputer technology worldwide. Byte, the international standard.